Hello, welcome to some Tech Call. Today we are going to solve the day 31 of August LeetCode challenge. So today's problem name is delete node in a BST. So basically we need to write one algorithm using which we can delete one particular node from our binary search tree. Okay, so let's try to understand the problem in more details, and then we will try to design one algorithm for the same. Okay, so this is our example, right? Initially, so if you represent the array, the input array as a tree, it will be look like this, right? So you can see 5 is the root node, then left node is 3, then right node is 6, like this. Okay, so since it's a BST, binary search tree, we need to keep in mind one thing, that the left node will be always less than the root node, and right node will always be right child node will be greater than our root node. Okay, so this is the property of BST. So suppose this is our tree and we need to delete the node 3. Okay, so how we can delete the node 3? So basically we will start from root and we will check is the value, right? So I can see that 3 is less than 5, so that means 3 will be, since it's a BST, so like binary search, right? Only in the left side we need to traverse the left side or left child. Okay, so then we will come here, and here I can see, okay, 3 is matching, right? So we need to delete this node basically. So then if I delete this node, then I need to replace this node, right? So I need to make a new root in, so either it can be 2 or it can be 4 also, right? So okay, so if I make it 2, right, so then how it will look? So it will be, so means 2 will come here and 4 will remain here, and this side will become null. Okay, so this can be one answer. Or what we can do, we can move 4 to here and this will be null and it will remain 2, right? So you can see the example also, right? So both answers are accepted. Okay, so either it can be like this or it can be like this. Okay, so this is the problem statement, and let's try to solve it. So basically what we are going to do, so again I will start traversing from the root. Then I will check that my key is in the left side or right side. Then I will so suppose I found this actual key, right, 3. Then suppose so let's take the second example, okay, and the bigger example. Okay, so you can see that this is my tree, right? I want to delete the number 15. Okay, so how we can delete 15? Okay, so I will come 25 and see, I will check, okay, 15 is less than 25. Okay, so then I will come here and I found this. Now I need to replace it. Suppose I am replacing from the right side. Okay, so what I will do, so I can't directly move 22 here, right, because I need to balance the tree also, right? Always the left side will be smaller. So in this case I will try to find the right minimum value in the right side, and I can make that as a root, right? So I will traverse this portion of tree and try to identify the minimum value. So minimum value will be always in the left side. Okay, so what we can do, I can find that, okay, 17 is my minimum value, right? Now I can update that value as 17 and remaining tree will be same, and later once we done our update, we can delete this node, right? So it will be look like this. So how it will look like, so let's me quickly draw that. Okay, so after that it will look like this, right? So we will delete 15 and that will be replaced by 17, and remaining right side tree will remain same. Okay, so this is the algorithm we are going to follow today. Okay, so let's write the code using Java quickly. So what I need to do, as first I need to check some edge condition, right? That if my root equals to null, that means we can return root, right? We don't need to perform anything. And what else? And now we need to actually traverse the tree, right? So I will check if my root, so if my key is greater than root dot val, that means I need to traverse in the right side. Okay, so I will call method root dot right, and it should be delete node, and we need to pass our method also, right side node, right, and we need to pass our key. Similarly we need to check it for left side also, right? So else if suppose my key is less than root dot val, that means we need to traverse in the left side. That means key will be in the left side. Okay, since it's a BST, so it should be root dot left should be delete node, and we need to pass root dot left since we are traversing in the left side, and we need to pass the key also. Okay, so now once, and suppose so in this case, for this case means this is not matching, and suppose I found this key, right? I found the exact match. Then we need to find out the new root, right? So let's write logic for the same. Okay, so else, that means key is equals to root value, right? So if it is key is equals to root value, then we will check that if my root dot left equals to null. If my root has don't have any child, then we can directly delete it, right? We don't need to make new root. Okay, so it should be root dot left equals to null and root dot right equals to null. In this case, we can make root as null, right? Since we don't need to and choose new root. Okay, so root equals to null. And else if it is not, then we need to check, right? So what we need to check, else if root dot right not equals to null. So you can either do left or right also, right? In this case we are considering right side first. Okay, if right side is null, then we will go to check the left side, but you can do the in reverse order, right? You can check left, then if left is not there, then you can check right side. Okay, so it's either or. So okay, so if it is root dot right, so suppose in this case I found that okay 15 is my key and I need to choose new root, right? So I need to traverse this right side portion, right? So I will do that and I will traverse and find the minimum value from here, right? So I need to find out the 17. Okay, so what I will do, so I will create one separate method using which we can find the minimum value from the right side tree and it will return the value, right? So basically it will return the 17. Okay, so I will define it later. So I will name it as find mean, right? Probably, and we are passing only root in this case. And once we found our new value, actual value, then again we are going to call our delete node method, so that again I will traverse the tree and I will delete this particular node, right? I will make this null. Okay, so then we can return. So we are doing that only. So it should be root dot right equals to, I am going to call the same method delete node. In this case I am going to pass the root dot right value and I am going to pass the root dot val. Okay, so 17 in this case, so we are going to delete 17. Okay, and suppose in some case my right side node is null, then we need to do it for left side, right? So if my root dot left not equals to null, then again we are going to calculate. So in case of left side, we need to consider the maximum value, right? So it should be root dot val and it should be equals to find max left, and we need to pass again the root dot left. Okay, and once we are done, we are going to call the same method to delete that particular node. Okay, so it should be equals to delete node and we need to pass root dot left and root dot val. Okay, once we are done, we can return our actual root, right, as a result, since we need to return tree node only. Now quickly implement this, write the implementation for this find mean and find max function. So it should be private method since in the same class, and it will return type will be int, and we need to pass one thing only, tree node root. And in this here we are going to check that if, so let us update the it first. So root should be, since we are traversing the right side, so it should be root dot right. Okay, now we will check that while my root dot left, because we need to find the left value, right, left smollett value not equals to null, then we will going to update it, right? So it should be root dot left, root equals to root dot left, right? And after that we are going to return root dot val. Okay, similarly we need to do the same for find max left also. So let's quickly write that also. So it should be private, then return type should be similarly int, and name should be like this, and we are passing tree node only, so it should be root, and in this case we are traversing the left side, so it should be root equals to root dot left. Initially we will traverse the left side, then we are going to check the maximum value from the right. Okay, so it should be root equals to root dot right not equals to null. Okay, and we will traverse in the right direction only in this case. Okay, so root should be root equals to root dot right. Okay, and once we are done, we are going to return root dot file. Okay, I think that's pretty much. Let's quickly run it and check whether it's compiling or not. Okay, it's giving me some compilation error. Let me quickly fix that. So it should be equals to null. Okay. Okay, it's giving me expected answer. Let's quickly submit our answer and check whether it's accepted or not. Okay, so it should be only root, since we are doing root.left in our actual function. Let's submit it quickly and check. Okay, and our solution is accepted. So let's try to analyze the time complexity and space complexity first. Okay, so let's try to analyze our code, and that will probably give you much better understanding. So initially we are checking the root is not null. If it is null, then we are going to return the root. So this is basically supporting the edge cases. Now we will check that if it's my value is greater than root value, then I will traverse in the right direction. If it is the less than, then I will traverse in the left direction. So suppose we want to delete 15 here, right? So we will traverse left direction because 15 is less than 25. Okay. So now what next? Then I will check that it's both child is null or not, right? So if it's both child is null, then we can directly set that root null. Okay. So what that means? So suppose we have one like this, right? One value and one value like this. Okay. So probably think it like 1, 2, and think it like 1, and this is 4, right? And we need to delete 1. So in this case, I see that there is no child nodes for 1, right? So we can directly delete it, right? And tree will remain like this, 2 and 4. So to cover this kind of scenario, we are doing this, right? We are checking that both child are null or not. If both child are null, then we can directly set that to null, and we don't need to find out new root. Okay. So this is for that logic. Else what we will do? I can either move in the left, or I can either move in the right direction to find the new root. So in this case, we are giving priority to the right side. So if I have any value in the right side, then I will traverse in my right side tree, and I will find the minimum value, right, from the right side. I can see my minimum value is 17, and I will choose that value, and I will replace that value to the actual node. Okay. So we are doing that only, right? So you can check. We are checking by root.right if my root.right exists. Yeah, in this case my root.right is exist, right? Okay. So I will call my find min right. So what we are doing inside it, so we are passing the root value, right? We are passing 15 node, and we are starting from 20, right now. So I always know, since it's a BST, my minimum value will be always in my left side only, because always left side value will be less than the root value. So we are traversing to the left. So we are running while loop. So in this case, it will stop here only. But suppose if we have other node like this, then we will keep traversing to the extreme left. Then we will pick that value, right? In this case, I found my value is 17, and we are going to return that value. Okay. So we are going to root.value, returning root.value, and whatever value we have written, I assign that it as 17. Then again, I am calling my same function or same method to identify this 17 node and delete that node. So again, we are calling delete node method, right? So again, we will check, and we are searching for now 17 only, right? So I will again start from here, and I can see 17 is less than 20, so I will come again here. So this same logic will be executed, and again I will find 17 here, and 17 don't have any new node, any child node, so I can directly set it null, right? So using this logic. Okay, this logic. Okay. So this is, in this way we are doing it, right? And suppose in some cases if my right side is null, so then in that case I can traverse in the left side, and I can find out the maximum value. So in case of left side, my maximum value will be always in the extreme right? Okay, so I think that's pretty much for this code. If you like this video, please subscribe to our channel, and if you have still some doubt, then you can ask me in the comment section. Thanks for watching. Bye bye.